Hello, in this lecture we find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a polygon with 6 equal sides and 6 equal angles. That is to say, all of these sides of this hexagon are equal to each other. DE equals to EF equals to FA equals to AB and equals to BC, and all those 6 interior angles of this regular hexagon are also equal to each other. And we also know that one side of this polygon of this regular hexagon are equal to 2 units, therefore all the other sides must be also equal to 2 units, because of the fact that all the sides of any polygon hexagon are equal to each other. So here BC equals to 2 units, ED equals to 2 units, EF equals to 2 units, and FA equals to 2 units. Here DC also equals to 2 units, and CB equals to 2 units. And all the 6 interior angles of this polygon, of this regular hexagon, are equal to each other. Okay, and so one side of this regular hexagon is equal to 2 units, and we also know that line segment PB equals to 4 units, and our mission is to find out the length of line segment AP that is equal to X. We have to find out the value of X. Okay, so first of all we'll find out what is the sum of the angles, what is the sum of the interior angles of this regular hexagon. That is to say, what is the sum of those 2, 4, 6 angles. Okay, so here I will draw a regular hexagon that could be actually any regular hexagon. So this is a regular hexagon, A, B, C, D, E, F. It could be any regular hexagon. In order to find out the sum of the interior angles of this regular hexagon, we join points B and D together by a straight line. By joining points B and E, we created here 2 quadrilaterals, quadrilateral ABFE, this quadrilateral, and quadrilateral BCED. We know that the sum of the angles in any quadrilateral is equal to 360 degrees. That is to say, the sum of the angles in quadrilateral ABFE is equal to 360 degrees, and the sum of this quadrilateral BCED is also equal to 360 degrees. And in total, the sum of the angles on both quadrilaterals will be equal to 360 degrees, that is plus 360 degrees plus 360 degrees, that is 720 degrees. Therefore, the sum of the interior angles on this regular hexagon will be equal to 720 degrees. Okay? And because of the fact that any regular hexagon has 6 equal angles, 2, 4, 6, any polygon hexagon has 6 interior equal angles. In order to find out the size of one angle, we'll divide the total sum of the 6 angles, that is 720 degrees, over the total angles that are 6. 720 degrees over 6 is 120 degrees. That is the size of one angle. So each of those 6 interior angles are equal to 120 degrees in its size. Okay, so we can write down that this angle equals to 120 degrees. This interior angle equals to 180 degrees. This interior angle equals to 120 degrees. This interior angle equals to 120 degrees. This interior angle equals to 120 degrees. And finally, this interior angle, it is also equal to 120 degrees. In the next step, we'll extend side DC by a straight line. And you find this point as point L. DC is one out of 6 sides of this regular hexagon. So DC as a side of a regular hexagon, it is absolutely a straight line. Here DC is a straight line because it is one side of a regular hexagon. And when we extended DC by a straight line, the result must be a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So I can write down that DL is a straight line. Line segment DL is a straight line. And we actually have rule number 1 about straight lines. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on this side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of the straight line DL is point C? We have this angle, this is point C. Which angles we have at this side of the straight line DL at point C? We have this angle that is equal to 120 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. Therefore, this missing angle must be equal to 60 degrees. In order to complete the sum of the angles on this side of DL at point C to 180 degrees, the missing angle must be equal to 60 degrees. Okay. In the next step, from point B, we will draw perpendicular on DL. Again, from point B, we will draw perpendicular on DL. From point B, this is perpendicular on DL. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and DL as M. By doing this construction, we can here the right triangle CBM. Okay. So I copy the right triangle CBM in a new page and we'll analyze it. So this is actually the right triangle CBM that I copied from the original drawing. Side BC equals to 2 units because this is one side. It is one side of this regular hexagon, and we know that all the sides of this regular hexagon are equal to 2 units. This angle equals to 60 degrees according to rule number 1. This angle equals to 90 degrees according to our construction. So in this right triangle CBM, we know that cosine 60 degrees equals to CM over CB. Okay, cosine 60 degrees equals to CM over the hypotenuse CB. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and this is equal to CM. CM is the missing line segment, so we leave it as it is, over CB. CB equals to 2 units, therefore we substitute CB by 2. In conclusion, we found out that 1/2 equals to CM over 2. Here we will multiply this equation by 2, and we get that 1 equals to CM, or CM equals to 1 unit. CM equals to 1 unit. You can write in the original drawing that CM equals to 1 unit. We continue to focus on the right triangle CBM. In the right triangle CBM, sinus 60 degrees equals to BM over the hypotenuse CB. Sinus 60 degrees equals to square root of 3 over 2. So we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to BM. BM is the missing line segment, so we leave it as it is, over CB. CB equals to 2 units, so we substitute CB by 2. In conclusion, we found out that square root of 3 over 2 equals to BM over 2. Here we will multiply this equation by 2, and we will get that BM equals to square root of 3 units. BM equals to the square root of 3 units. Here we can write down in the original drawing that BM equals to the square root of 3 units. Okay. In the next step, we will focus on the right triangle PMB. Right triangle PMB. This angle equals to 90 degrees according to our construction. The length of PM equals to PC plus CM. CM equals to 1, PC is unknown, so we'll define PC, the length of PC as A. Therefore, the length of PM is PC plus CM, that is to say it is A plus 1. The length of BM is equal to 3 units, and the length of the hypotenuse PB is equal to 3. So we copy the right triangle PBM in a new page, and we will analyze it. This is the right triangle PMB that I copied from the original drawing. Here we will implement the Pythagoras theorem in order to find out the value of A. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle PNB is PB. Therefore, the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus MB squared. PB equals to 3 units, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PM equals to A plus 1, therefore PM squared is A plus 1 squared plus MB squared. MB equals to the square root of 3 units, therefore MB squared equals to the square root of 3 squared. In conclusion, we found out that according to the Pythagoras theorem in the right triangle PMB, 9 equals to A plus 1 square plus square root of 3 square. So 9 equals to A plus 1 square plus the square root of 3 square is 3. So 9 equals to A plus 1 square plus 3. Here we subtract 3 from this equation and we get that 9 minus 3 is 6, so 6 equals to A plus 1 square. Here we take out of this equation and we get that the square root of 6 equals to A plus 1. Here we subtract 1 from this equation and we get that A equals to the square root of 6 minus 1 units. So we found out the value of A. We can write down the original drawing that A equals to the square root of 6 units minus 1. Okay. In the next step, we join points A and C together by a straight line. By joining points A and C, we created the triangle ABC. This is triangle ABC. Angle ABC, this angle is one out of the 6 interior angles of the regular hexagon. Therefore, it is equal to 120 degrees because of the fact that all the interior angles of this regular hexagon are equal to each other, and each of them is equal to 120 degrees. So this angle equals to 120 degrees, AB equals to 2 units, and BC equals to 2 units. So I copy the right triangle, this is not the right triangle, I copy triangle ABC, and in your page we implement the law of cosines in this triangle ABC in order to find out the length of side AC. Okay. So this is actually triangle ABC that I copied from the original drawing. We will implement the law of cosines in order to find out, in this triangle ABC, in order to find out the length of side AC. So what is the law of cosines? Actually, the law of cosines is true in any triangle. So if we have here triangle ABC, that could be any triangle, not necessarily our triangle, but any other triangle. This is triangle ABC. The length of side AB is A units, side AC equals to 3 units in its length, and side BC equals to 3 units in its length, and the angle between side AB and side AC is theta. Then according to the law of cosines, that it is true in any triangle. C square equals to A square plus B square minus 2 times A times B times cosine theta. Repeat again, in any triangle, C square equals to A square plus B square minus 2 times A times B times cosine theta. You can implement the law of cosines in our triangle, triangle ABC, in order to find out the length of side AC. According to the law of cosines, in our triangle ABC, AC square will be equal to AB square plus CB square minus 2 times AB times CB times cosine 120 degrees. So this equation is the implementation of the law of cosines in our triangle ABC. So AC square equals to AB square. AB is 2, therefore AB square is 2 squared, that is 4, plus BC square or CB square. CB is 2, therefore CB square is 2 squared, that is also 4, minus 2 times AB is 2, and CB is 2, times cosine 120 degrees. The value of cosine 120 degrees is minus 1 now. Okay, so if I know that AC square equals to 4 plus 4 is 8, minus, here we have minus times minus is plus, so this expression will be a positive number. So 2 times 2 is 4, and we have here 2 over 2 is 1, so 2 will get cancelled. In total, this expression equals to 4. So AC square equals to 8 plus 4, that is 12. AC square equals to 12. Here we will substitute 12 by 4 times 3. AC square equals to 4 times 3. Here we take a root out of this equation, and we get that AC equals to the square root of 4 times 3, and the square root of 4 is 2, so we can take 4 out of the root. Inside the root we left only with square root of 3. So in conclusion, we found out that AC equals to 2 times square root of 3 units. AC equals to 2 times square root of 3 units, so we can write down in the original drawing that side AC equals to 2 times square root of 3 units. I'll copy triangle ABC again in order to find out the size of those two angles. Okay. angle ABC equals to 120 degrees. So this is triangle ABC that I copied from the original drawing. In triangle ABC, side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we know that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is x, then this angle must be also equal to x. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle ABC. In triangle ABC, the sum of the angles are x plus 120 degrees. In total, they must be equal to 180 degrees. Here we subtract 120 degrees from this equation, and we get that x plus x is 2x, and it is equal to 180 degrees minus 120 degrees, it is 60 degrees. Here we divide this equation by 2, and we get that x equals to 30 degrees. X equals to 30 degrees. Here also x equals to 30 degrees. So we actually found out that this angle, this is actually angle ACB, equals to 30 degrees. I write it down in the original drawing. This angle ACB equals to 30 degrees. What is the size of this angle? This is actually angle ACP. This angle ACP will be equal to the big angle PCB, that is equal to 120 degrees, minus the small angle ACB, that is equal to 30 degrees. So PCB minus ACB equals to the missing angle PCA. I will write it down. The big angle PCB this angle PCB, this is equal to 120 degrees, minus the small angle ACB, that is equal to 30 degrees, will be equal to the missing angle, this angle PCA. Angle PCA. Repeat again. The big angle PCB, that is equal to 120 degrees, minus the small angle ACB, that is equal to 30 degrees, must be equal to angle PCA. So angle PCA equals to 120 degrees minus 40 degrees, it is 90 degrees. So angle PCA is the right angle. This angle, it is the right angle, it is equal to 90 degrees. Okay, this is the right angle. Angle PCA is the right angle. And because of the fact that angle PCA is the right angle, therefore triangle PCA is the right angle. This triangle PCA is the right angle, therefore we can implement the Pythagoras theorem on the right hand triangle PCA. So I copy triangle PCA in the equation and implement the Pythagoras theorem on this right triangle PCA. So this is actually the right hand triangle PCA that I copied from the original drawing. We will implement the Pythagoras theorem on this right triangle PCA. So here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. The hypotenuse in this right triangle is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC squared plus AC squared. So according to the Pythagoras theorem, AP squared equals to PC squared plus AC squared. AP equals to x, that is the line segment that we are looking for. Therefore AP squared will be equal to x squared, and it must be equal to PC squared. PC equals to square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared plus AC squared. AC equals to 2 times square root of 3, therefore AC squared equals to 2 times square root of 3 squared. In conclusion, found out that x squared equals to square root of 6 minus 1 squared plus 2 times square root of 3 squared. And here we find out the value of square root of 6 minus 1 squared according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. In our specific expression, the value of a is square root of 6 units and the value of b is 1. And according to this algebraic identity, we get that square root of 6 minus 1 squared equals to a squared. Here a is square root of 6, therefore a squared is square root of 6 squared, that is 6. Plus b squared, b is 1, therefore b squared is 1 squared, that is 1, minus 2 times a is square root of, this is minus 2 times ab. A is square root of 6 and b is 1. So in conclusion, we found out that this expression square root of 6 minus 1 squared equals to 6 plus 1 minus 2 times square root of 6, and we have to add 2 times square root of 3 squared. 2 times square root of 3 squared is 2 squared, that is 4, times square root of 3 squared, that is 3. 4 times 3 is 12. In conclusion, we found out that x squared equals to 6 plus 1, that is 7, and 7 plus 12 is 19, minus 2 times square root of 6. So x squared equals to 19 minus 2 times square root of 6 squared. Here we take out of this equation and we get that x equals to the square root of 19 minus 2 times square root of 6. So the answer to the question is that x AP that is equal to x equals to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, it is equal to 3.755 units. Okay. Here x equals to 3.755 units, or it is equal to square root of 19 minus 2 times square root of 6 units. We finished to answer this question. In the next step, we'll summarize the lecture. In the drawing, we have a regular hexagon. Repeat again that a regular hexagon is a polygon with 6 equal sides and 6 equal angles. Okay, in this regular hexagon we know that one side of this regular hexagon, A, B, C, D, E, F, equals to 2 units. Therefore all the other sides must be also equal to 2 units, because of the fact that all the 6 sides of the regular hexagon are equal to each other, and also all of its 6 interior angles are also equal to each other. And we also know that PB equals to 3 units, and our mission is to find out the length of side AP that is equal to x, so to find out the value of x. Okay, so first of all, we found out the sum of the interior angles, the sum of the 6 interior angles in this polygon hexagon, or the sum of the interior angles in any polygon, in any regular hexagon. So this is a regular hexagon A, B, C, D, F, and we join points E and B together by straight line. By joining points E and B, we can add here 2 quadrilaterals, quadrilateral A, B, F, E, this quadrilateral, and quadrilateral B, C, D. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in this quadrilateral A, B, F, E, it is equal to 360 degrees. Plus the sum of the angles in this quadrilateral, that is equal to 360 degrees also. In total, the sum of the angles on those both quadrilaterals will be equal to 360 degrees plus 360 degrees, that is 720 degrees. This will be also the sum of the angles in this regular hexagon. So the sum of the angles in any regular hexagon equals to 720 degrees. Okay, and because of the fact that any regular hexagon has also 6 equal angles, so if we divide the sum of the total angles, that is actually 720 degrees, by the number of the angles, that is 6, we will get the size of one interior angles of any regular hexagon. So 720 degrees over 6 is 120 degrees. For that reason, all the interior angles are equal to 120 degrees in their sizes. Each of them is equal to 120 degrees. So here we can write down that all the interior angles, all the 6 interior angles in this regular hexagon are equal to 120 degrees. And also all the sides of this regular hexagon are equal to 2 units. Each side equals to 2 units in its length. In the next step, we extended side DC by straight line until point L. So by extended side DC, we created here line segment DL. DC is one side of this regular hexagon, and DC is a side of a regular hexagon. It is absolutely a straight line. Okay, DC is a straight line, and when we extended the straight line DC by straight line, the result DL must be also equal a straight line. So here we can write down that DL is a straight line. Okay, and we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. This angle equals to 180 degrees because it is 1 out of 6 interior angles of this regular hexagon, and each of the interior angles are equal to 180 degrees. So this angle, that is the interior angles of this regular hexagon, equals to 120 degrees. Plus the missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule number 1. Okay, so here this missing angle must be equal to 180 degrees. In order to complete the sum of the angles on this side of the straight line DL at point C to 180 degrees, the missing angle must be equal to 60 degrees. Okay, so this angle equals to 60 degrees according to rule number 1. Then from point B we draw perpendicular on DL. Again, from point B we draw perpendicular on DL. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. When doing this construction, we get there the right triangle BCM. So I copied triangle BCM in a new page and we analyzed it. This is triangle BCM that I copied from the original drawing. This angle equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees according to our construction. And here BC equals to 2 units because this is one side out of the 6 sides of the regular hexagon, and all this the sides of the regular hexagon are equal to each other. Each of them is equal to 2 units. So in this right triangle BCM, we know that cosine 60 degrees equals to CM over CB. Cosine 60 degrees equals to CM over CB. Cosine 60 degrees is equal to 1/2, so we substitute cosine 60 degrees by 1/2, and it is equal to CM. CM is the missing line segment, so we leave it as it is. CB equals to 2 units, so we substitute CB by 2. In conclusion, we found out that 1/2 equals to CM over 2. We multiply this equation by 2 and we found out that CM equals to 1 unit. Here, CM equals to 1 unit. Okay? Then in this right triangle CBM, sine of 60 degrees equals to MB over CB. Sine of 60 degrees equals to MB over CB. The value of sine of 60 degrees is square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, and it is equal to BM. BM is the missing line segment, so we leave it as it is, over CB. CB is 2, so we substitute CB by 2. In conclusion, we found out that square root of 3 over 2 equals to BM over 2. Here we multiply this equation by 2, and we found out that BM equals to the square root of 3 units. BM equals to the square root of 3 units. We can write down here that BM equals to the square root of 3 units. Okay, in the next step, we focused on the right triangle PMB. This right triangle PMB. What is the length of side PM? PM equals to PC plus CM. CM equals to 1 and PC is unknown. So we define the length of PC as A, and therefore PM will be equal to PC plus CM, that is to say will be equal to A plus 1. MB equals to the square root of 3 units. PB, the hypotenuse PB equals to 3 units according to what is given as the equation, and this angle equals to 90 degrees according to our construction. So I copy triangle PMB in a new page and we implemented the Pythagoras theorem on this right triangle PMB. This is triangle PMB that I copied from the original drawing. PM equals to A plus 1, MB equals to the square root of 3 units, and the hypotenuse PB equals to 3 units. Here we implemented the Pythagoras theorem on this right triangle PMB. So here by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PM squared plus MB squared. So according to the Pythagoras theorem, in this right triangle PMB, PB squared equals to PM squared plus MB squared. PB equals to 3, so PB squared equals to 3 squared, that is 9, plus PM squared. PM equals to A plus 1, therefore PM squared is equal to A plus 1 squared, plus MB squared. MB equals to the square root of 3, therefore MB squared equals to the square root of 3 squared. In conclusion, found out that 9 equals to A plus 1 squared plus square root of 3 squared. So 9 equals to A plus 1 squared, and the square root of 3 squared is 3. So 9 equals to A plus 1 squared plus 3. Here we subtracted 3 from this equation and found out that 9 minus 3 is 6, and 6 equals to A plus 1 squared. Here we took out of this equation and found out that the square root of 6 equals to A plus 1. Here we subtracted 1 from this equation and found out finally that A, the missing line segment, equals to the square root of 6 minus 1. So here we can find out that A, line segment PC is equal to A, it is equal to the square root of 6 minus 1 units. Okay, then we join points A and C together by a straight line. By joining points A and C, we created triangle ABC. This is triangle ABC. This angle ABC equals to 120 degrees because it is one out of 6 internal angles of the regular hexagon ABCDEF. And all the angles of this regular hexagon are equal to each other and they equal to 120 degrees each of them. So therefore angle ABC equals to 120 degrees. AB equals to 2 units and BC also equals to 2 units because those are the two sides of the regular hexagon and they are all equal to 2 units. So this is triangle ABC, this is the coordinate from the original drawing. AB equals to 2, BC equals to 2 and this angle ABC equals to 120 degrees. We implemented here the law of cosines in order to find out the length of side AC. According to the law of cosines, that is shown in any triangle, this is triangle ABC that could be any triangle. Side AB of this triangle ABC equals to 3 units, AC equals to 3 units in its length, and BC equals to 3 units in its length. So, and the angle between side AB and side AC, this angle equals to theta. And according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. We will implement this law of cosines in this triangle ABC in order to find out the length of AC. And according to the law of cosines, we will get that AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. Okay? So AC squared equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus CB squared. CB is 2, so CB squared is 2 squared, that is 4, minus 2 times AB is 2, and BC is also 2, times cosine 120 degrees. Cosine, the value of cosine 120 degrees is minus 1 half, so we substitute cosine 120 degrees by minus 1 half. In this expression we have minus times minus, that is plus. So this expression is a positive number. So 2 times 2 is 4 and 2 over 2 is 1. So those 2's will cancel. In total this expression equals to plus 4. So in conclusion, AC squared equals to 4 plus 4, that is 8, plus this expression equals to 4. So AC squared equals to 8 plus 4. So AC squared equals to 8 plus 4, that is 12. We substitute 12 by 4 times 3. So AC squared equals to 4 times 3. Then we took out of this equation and found out that AC equals to the square root of 4 times 3. The square root of 4 is 2, so we can take 4 out of the root. And in conclusion, we get that AC equals to the square root of 4 is 2, and inside the root we left only with 3. In conclusion, we found out that AC equals to 2 times square root of 3 units. So here, AC, the length of AC, it is equal to 2 times square root of 3 units. Okay, then I copied triangle ABC again in order to find out the sizes of those two angles. This is triangle ABC that I copied from the original drawing. This angle equals to 120 degrees, and we know that side AB equals to side BC. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is x, then this angle must be also equal to x. And you also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC, the sum of its angles must be equal to 180 degrees. So the sum of the angles of triangle ABC is x plus 120 degrees, and it must be equal to 180 degrees. X plus x is 2x, so 2x plus 120 degrees equals to 180 degrees. We subtracted 120 degrees from this equation, and we found out that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. We divided this equation by 2 and we found out that x equals to 30 degrees. So this angle is x, that is equal to 30 degrees, and this angle is x, that is equal to 30 degrees, and therefore it is equal to 30 degrees. So angle ACB equals to 30 degrees. So we can write here that this angle ACB, this is angle ACB, and angle ACB equals to 30 degrees. Okay? So what is the size of angle PCA? The size of this angle PCA. This angle PCA will be equal to the big angle PCB minus the small angle ACB. Again, angle PCB, the big angle PCB minus the small angle ACB will be equal to this angle PCA. I'll repeat again. Angle PCB minus angle ACB equals to angle PCA. Angle PCB equals to 120 degrees. Angle ACB equals to 30 degrees. And therefore, PCB minus ACB is 120 degrees minus 30 degrees. That is 90 degrees. So we found out that the missing angle PCA equals to 90 degrees. This angle is the right angle. Angle PCA equals to 90 degrees, and therefore the green triangle PCA is the right angle. So we can implement this right green triangle, the Pythagoras theorem. So I copied this green right triangle PCA in a new equation. We implemented in this green right triangle PCA the Pythagoras theorem. This is triangle PCA, that is copied from the original drawing. AP is the missing line segment that we are looking for, and it is equal to x. AC equals to 2 times square root of 3 units. And we have already found out that PC equals to 8, and it is equal to square root of 6 minus 1 units. So here, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say it must be equal to PC squared plus AC squared. So according to the Pythagoras theorem, in this right triangle ABC, AP squared equals to PC squared plus AC squared. AP equals to x, therefore AP squared is x squared, and it is equal to PC squared. PC is square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared plus AC squared. AC is 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. We found out the value of this expression, square root of 6 minus 1 squared, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. In our specific expression, a equals to square root of 6 and b equals to 1. And according to this algebraic identity, a minus b squared equals to a squared plus b squared minus 2 times ab. This expression, square root of 6 minus 1 squared, will be equal to a squared. And a equals to the square root of 6, therefore a squared is square root of 6 squared, that is 6, plus b squared. B is 1, so b squared is 1 squared, that is 1. So it is 6 plus 1 minus 2 times ab. Minus 2 times a is square root of 6, and b is 1. So it is minus 2 times square root of 6. So in conclusion, we found out that square root of 6 minus 1 squared, according to this algebraic identity, it is equal to 6 plus 1 minus 2 times square root of 6. Therefore, x squared equals to 6 plus 1 minus 2 times square root of 6 plus 2 times square root of 3 squared. 2 times square root of 3 squared equals to 2 squared, that is 4, times square root of 3 squared, that is 3. 4 times 3 is 12. So x squared equals to 6 plus 1, that is 7, and 7 plus 12 is 19. So it is x squared equals to 19 minus 2 times square root of 6 units. Okay, here we took a root out of this equation and found out that x, the line segment that we are looking for, this line segment AP that is equal to x, it is equal to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, the length of line segment AP that is equal to x, it is equal to 3.755 units. Okay? Thank you very much.